So, good morning, everyone.
Good morning.
Good morning. So, today it's our last session of bioinformatics for genomic classes. And then I will start by giving you a small lecture about how to write scientifically. The goal is not to turn you as an expert of scientific writing, but the goal is to give you some key aspect of when you write in science, how you write in science, how to write scientifically. It's okay. So I will share my screen first. Sharing the screen. Which one? It should be maybe that one directly. Yes. Did you have my screen? Yes, no.
Yes.
Okay. So before that, so the aim of this courses, we have several aims. The first one, uh, we have three aims in fact. But the first one, it's someone want to get in. Yes, I have three students more, so I should let them get in the class. So good morning for late student. We have three objectives in this skill, or three skills. If you have those three skills after this course, it should be really, really great, in fact. So the first one is to give you a key concept or a methodology used in bioinformatics, okay? How BLAST it's a little bit working behind, how multiple alignment it's a little bit working behind, or how to perform a research domain, for instance. So the second one, it's how to analyze your results. What are the key points? And then one of the important things of what we see in this class is with the same, if you have the same results, you can analyze it in several ways. This is the case for BLAST, you see, or for multiple alignment, depending of your biological question. It's okay? So you should really keep that in mind. In bioinformatics, you can have only one result, but from one result, you can extract several aspects of your data, depending of the biological question you have behind. It's okay? And then the third aim of the class is to show you how to write in science, okay? How to summarize all of the information, writing, for instance, how to make the table, the figures, and how to add your legend. And so it's okay for everyone. So as you see, before starting that, I have some remarks. So you should avoid we as possible when you are writing. It means that you should try to write in the passive way. It's a passive form, okay? So avoid I do this, I do this. Sometimes you can say we do that, but you should avoid it as possible you can. You should also avoid repeated sentence. Okay, it's not possible to say the ORF1 content or the size of ORF1 is 250 amino acid. The size of ORS2 is 150 amino acid. The size of, avoid that. those kind of repeated sequence. You can only write in simple ways the size of ORF 1, 2, 3 are 100, 200, or 300, and then a comma respectively. Okay, this is one way. So you should avoid repetitive sequences. You should also avoid the message style. What I call message style, so you always send a message and so on, write some comment, and all of your sentence should have a subject, a verb, or a complement. Not something like just a verb with a complement, or something like only the subject and the verb. No, you should have a complete sentence. Okay, so avoid the message style when you are writing, and then always cite the source of your information, and keep in mind that Wikipedia, it's not a scientific source. It's not proven. It's unreliable. So when you have a source of information, a scientific source of information, it should be maybe a website, but a scientific website, a database, for instance. It could be a publication, it could be a book, scientific books, and so on, but not Wikipedia. Okay? You should also pay attention about obsolete or outdated web link. I wrote that before. When you perform your analyzing using BLAST, for example, or using protein domain search, you get your analysis. It's a web. You have a web link for that. That web link still active for only maybe 48 hours or 72 hours, but not more. So if you give us, or when you are writing, if you give those kind of link, after 3 days, those kind of links are outdated. Okay? It's not, those kind of things is not anymore active. So we cannot click on that and get the results. So pay attention of that. That is one of the reasons why all of your raw data are in text. So you can turn it in text and then copy it and put it in your annotation form. It's okay? And then the last one, you should reread your text to avoid mistake, to avoid misunderstanding, short sentence, to avoid repeated sentence sometimes, and so on. Okay, so one of our advice is that you read again your annotation to be sure that everything is fine. It's okay. So you have three aspects when you are writing in science: the protocol, your raw results, and then the analysis of your results. So we are going to go into those three aspects. Some of them are already been shown in the rule books, but I will give you other aspects that could be fine for you, that could be important when you are writing. So the first thing in the protocol is that when you write a protocol, it should be, everyone should be able to reproduce your results. That is really important. Everyone in the world. It means that you should put all of the information so that everyone who wants to reproduce it can apply your protocol and get the same results. Okay? So, in the case of which you have numeric experience, you should for instance, have A, B, C in your protocol, but in the same time, you should have A, B, C, etc. in your raw results. It means that you should have a link between your protocol and the raw results. Okay? Everything in your protocol you should have the corresponding aspect in the raw results. Okay? So for each experience, you should have it in raw results and so on. Even if you have nothing, remind that nothing as a raw result, it's also a result. Okay? So it means that you should put A, B, C, and then you add no result or not no significant results or no significant alignment, something like that. So about the raw result, as I taught you, what you called a bad result or a non-significant result remain also a result. It means you should add it. So this part, it's really mandatory to show it in your scientific annotation or your scientific results, because it's the only way to support your conclusion, or it's the only way to make your scientific good faith. It means that we cannot believe on you if you don't have the raw result, the exact raw result. Don't modify it. It could be in text. It could be a link if it's an active link in every times, but it's a mandatory aspect of your analysis, of your writing, to get the raw result. Okay? It's also important for your scientific demonstration. And then, based on your raw result, you should build table, you build tables, figures, and so on. So everyone should know where those table and figures are, in many cases, the summary of your raw results. It's another way of presenting your raw results. And then the only way to support your table and figures is to get the raw result. It's okay, so it's really important. And then the results analysis, the main part. So for that, you have different aspects. The first thing, it's the biological question. Because from raw results, as I told you at the beginning, in bioinformatics, or even in another field of science, with one result, you can extract you can decipher different analyses based on the biological question you have. So it means that to analyze your result, you should first have in mind what is the biological question, and then structure your result analysis based on the biological question, not only based on what you are observing, what you observe in your raw results or in the protocol. It's your results analysis, once again, should be based on the biological question. That is why you see here on my slide, biological question 1, biological question 2, you can get biological question 3, and so on. And then from each biological question, you should have, you therefore get the analysis based on that. So the first thing is to make a kind of overview of your results. You describe of your results in general. So we will come in details, a little bit in details on about that. But every time when you start the biological question to get the analysis, you should make kind of overview of your results. And then you make a kind of zoom on one aspect of your biological question. You have the general biological question, you can have the sub-biological question, and then you make a zoom on that. And then by describing the experimental evidence from, of course, from your results or from your table and figures, and from that, you can have also several zoom on different aspects you want to highlight in your results. Okay? It's a little bit clear for everyone. We will see the example maybe on the next slide. And then you will see what I'm talking about. Like this, it's a little bit general, but we will see how it's going. So, to summarize, here you have a biological question. From that, you get the overview. From that, you make a zoom on one aspect of your analysis. You can have several zoom on aspect 1, on 2, and then you close that biological question with a small conclusion on the biological importance of your results, okay, in order to resolve the question or beyond the question. And then you move to biological question 2, etc. Okay? Here, the biological question 1 could be the identification of your open reading frame, the feature of your open reading frame, and so on. And the biological question 2 can be the homologs you have, or can be the functional domain you get in your data. So here, this is a part of the rule book to show you that what you already did now follow exactly what I'm talking about here in this slide. As you can see, in different aspect item of your annotation, you always have the overview of your result. This is about the domain analysis, and then describing your results based on the table. The table summarizes what you have in the row results, and then you have what we call the result interpretation with zoom 1. This is one aspect of your results, the selected domain, and then another aspect is the rejected domain, and another aspect is, in fact, the biological function of the domain of your open reading frame. And then you make a small conclusion about what is the function of your domain and how to cross those information with the BLAST result. Okay? So, some of the aspects, imagine that you do not have rejected domain. It means that you will not put a rejected domain in your writing. So don't be forced to add something for which you don't have the results, or for which you don't have the data. If you don't have the data, you don't write about it, and then it's also fine. Okay? So, the overview, it means highlight the general view of the data, the nature of the object you have inside. If it's about protein domain, it means you should cite all of the nature of the protein domain you have, the range of value, how many you have. I have 4 domains, and the 3 main aspects, maybe most of the domain are transporter domain or are ATPase domain and so on. Okay, this is a general view. And then after that, so the reader should be able here to appreciate the general content of your table, figure, row, result, without looking them. It means when you are making the overview, everyone should have a general view of your raw results, of your table, of your figures, without getting them. Because in many cases, when you are reading a papers, what I call here the raw results are in supplemental table. Even if they are in supplemental table, your result is like a supplemental table. Everyone should be able to read your text and to appreciate it, what you really have in your supplemental table, without looking the supplemental table. Now, if someone wants to get the details about that, they will go in, in the supplemental table, look the table or your result to get a little bit more details. So the zoom of one aspect means that you first remind the scientific question or analyze the aim of your analysis. You give the major scientific observation, their nature, their proportion, the value, the statistical significance. I hope it's clear for everyone. If you are making like taxonomic diversity of your homologs, giving the major scientific observation, it's giving the 5 or the 3 or 5 main taxonomic clades with higher homologs. That is the proportion. It's about 50% compared to the total. The value 300, and the range of e-value it's between -100 to -80 or something like that of the statistical significance. So you just give the major or the main point of your observation, and then how these observations are important and allow to get the answer of the biological question. And then, of course, the small conclusion at the end. So I come back, I already talked, I come back here. This is the domain again. You should give the size of the domain, the e-value for the selected domain, how many they are, what is the biological function. It means you should go into the domain object in biological database to get the function, and then you should also cite your sources or something like that. Okay? So you can do that you should do that for each item: open routing frame, domain analyzers, BLAST, taxonomic diversity, phylogeny, and so on. And then at the end, you have the general conclusion of your analysis. And then here, the 3 main object of the annotation is the coding the open reading frame. I mean, give the features of your open reading frame, get the protein function, and then get the taxonomic diversity and the taxonomic origin of your family. It's okay? For each of that, you have several tools you use. Okay? As you can see, for coding for open reading frame, you have ORF Finder, BLAST again, NR, and multiple alignment. From protein function, you have interpro, domain search to get the functional domains, the BLAST again SwissProt, and the BLAST also again NR. But in this case, in the functional diversity, you have the multiple alignment, okay, to get the conserved site and then the conserved amino acids in your protein, and then the gene ontology annotation. And then from the taxonomic diversity and the taxonomic origin, you have the blast again, NR, but with the taxonomic diversity aspect, you have the multiple alignment, the curation. This is a G blocks, and then the phylogenetic reconstruction to get the origin of your fragment, and then the closest organism. It's okay? So in the general, your general conclusion, you should cross all of the aspects of each item. It means that in the coding open reading frame aspect, you should cross the information about ORF finder, blast again NR, and then multiple alignment, or summarize all of them together. It should be the same from protein function, and it should be the same from taxonomic diversity and taxonomic origin. It means that in your conclusion, you should have 3 main paragraphs. Each of the paragraph should be one of those 3 main aspects of your conclusion. It's okay? So 3 distinct paragraphs to resume your finding and then get the answer of the 3 main question. Okay, the coding fragment and the features, the function of your protein, and then the taxonomic origin. You should cross all of the evidence and check if fine. If they are not fine, don't worry about that. It's your results. You should say, they are not fine. I cross all of those aspects, but they are miss, or they are not going the same way. This is also a good conclusion. And then, of course, you have only 2,500 character maximums for that. It's okay. Do you have any question until here?
Yes, I have one question.
Yes.
In the result analysis, can we keep the number of the zoom, or we need to turn it into paragraph? Like your instruction, you write like 2.1, 2.2, for example. Can we keep that numbers, or we will rewrite it into paragraph?
For each zoom aspect, you should have 1 paragraph. Okay? If your 1 paragraph, I'm talking a general way. If your 1 paragraph is 1 page, I mean 1 writing page, normal A4 page, maybe sometime you can cut it in 2 to have zoom aspect 1 and zoom aspect 1 2. You see what I mean?
Yes, I understand.
You understand what I... So everything depends of the size. If you have only 10 lines, 1 paragraph, it's fine. But if you have 100 lines, it should maybe easier for good understanding for everyone that should read your writing, to separate it into several paragraphs, and then 1 paragraph which each aspect, zoom 1, zoom 2, 1 1, 1 2. Everything depends on what you are writing, in fact. But in our case, 1 paragraph will be enough. I mean in annotaton. It's okay?
Yes.
Okay. Another question? No? So, as you know, you are going to be, you need to have a mark at the end of the courses. So you are going to be evaluated based on your annotation in the practical exercise or practical work you are doing now. And for that, you have 2 rounds of evaluation. Okay. And then, as I remember, you have 3 or 4 days remaining to submit your work for the first round of evaluation. It's okay, and then we will correct evaluate your work, your job, and then send our remark to you for the second round of evaluation. As you will find in the rule book, you will have 2 weeks to perform your second annotation steps instead of 1 week. It was 2 weeks before, and then we have 2 weeks now. You should thank Dr. Tam, I don't know if you have Tam for that. Okay, so 2 weeks, and after that, you will submit your evaluation, your result or your analysis for the second steps or evaluation to get the final evaluation of your analysis. It's okay for everyone. 2 steps of evaluation. For each step of evaluation, you will have a mark for that. Evaluation 1, you have a mark. Evaluation 2, you will have also a mark. And then your final mark should be the average of the 2 marks. It's okay? I hope it's okay for everyone. Any question until now for that? Yes, no question. Okay, so this is a general aspect. Now, how you will be evaluated, or in other way, how, based on what you will be evaluated. You will be evaluated, as you can see on the slide, on how you apply the bioinformatic tools. This is the protocol, and how you put your raw results. It tells us how you apply the bioinformatic tools. If you make all of the method in the good way and so on, you will also be evaluated based on your scientific writing. This is the only way for us to see, based on what you are writing, if you understand what you are doing. The first thing is the respect of protocol. Okay? You can, in science, it's really important to respect the protocol. If you find a protocol in the paper or in the book or some elsewhere, and then you want to apply it again, it's important to respect exactly what is written in those protocols. Here, we give you the protocol, the general view of the protocol, and then you should respect it, okay? And then the raw results, we talk about that, how you put it in your data, and then the most important, your results analysis. In that case, it's how you extract the useful scientific information based on the raw results, based on the biological question. You should keep in mind what is the useful scientific information to answer my biological question. And then from that, you build the table, you build your figures, we show you some tables. We give you some advice for the table or figures, but you can by your own way put other tables, other figures as you want. It's okay for everyone. We just give you the key. Okay, some example, you can put your own table and your own figures. So the table should have a title, should be legend carefully so that we can find all of the information inside. Okay. So keep in mind that when we are evaluated it, when someone is read you, you are not close of me to tell me, in fact, I want to write it in fact. No. It should be clear so that by only reading you, I get all of the scientific information you want to highlight. Okay? So the grammar and the vocabulary, it's also really important. That's why I told you to read again your analysis before submitting it. Okay? And then the result analysis also show us the way you are writing. Keep in mind, the way you are writing tell us if you understand the concept of homologs, the concept of e-value, and so on. Okay? It means that my advice on our advice is to go back on the lecture and read it, your lecture, read the slide on the lecture to catch in your mind all of the concept we propose during the lecture, and then write your analysis based on that. You should have it in mind. Otherwise, you can write a sentence, and then it's completely misunderstanding based on the concept behind. That is important. So here it's important to read, to go back on the lecture and try to understand the lecture. It's okay? And then you have the final conclusion. I just talked about the final conclusion just before. It's okay? Any question until here? Yes, no? No? Okay, so I know.
Emmanuel, can I ask questions? So because students don't ask questions.
Yes.
So I should ask. So for the submission time.
Yes.
Remember, for the first evaluation, we give the date at the 21st of March, but on week hours. So we know that we have the French hour and Vietnamese hour. So we should give them a specific hour for the deadline.
It's do not matter. For me, it's the same. So the hours, as you will see the last day, now you have a counter in days. Okay? For the last day, you will have a counter in hours. And then for the last hours, you will have a counter in minutes, and so on. And then you have the counter on the top of the annotation web page. You already see that. So for me, it should be midnight here, but for you, it should be at 12 a.m. No. Yeah, it should be at the 12 a.m. Something like that. Yes.
It's actually 6 in the morning.
Yes, it should be at the 12.
Yeah, it's not different because I don't think we can stay up there.
Yes. So it should be at the 12 a.m. or something like that. Okay? So don't the don't what I mean. The answer of the question is you have a counter. Now it's remaining 3 days, so just follow the counter. As I told you, the last day the counter will be in hours, and then the last hours will be in minutes, and then the last minutes will be in seconds. But my advice is not to wait the last minute. Okay? Because the time is maybe we have 1 minute difference between my computer and your computer. So don't wait the very last time. You should submit something like maybe 30 minutes before to be sure, to be sure to that your submission is fine. And keep in mind that without submission, you will not be evaluated. It's not my fault. It's not of the fault of TAM. It's the fault of server. Okay? And since everything is done through the web, without submission, you are not count as a student that will miss that should be evaluated. And then it means that maybe you do not follow the courses. It's okay? Did I answer the question, Tam?
Yes, I think it's very clear.
Yeah. Okay, so the last aspect of the evaluation, since you will have 2 steps of evaluation. For the first step, you will get positive or negative comment or positive or negative remarks and so on. And all of that you will see will be in red. So you have different 2 types of comment. You have specific comment on one specific aspect. You have general comment on, and then you also have what I call pre-computed comment. It means that when we are evaluated, we already have pre-computed a comment inside the annotator. So when we find something that is wrong or something that is really successful, it's well written and so on, we only put it for you. And then that pre-computed comment, maybe you don't have all of the aspect of the comment you should answer, maybe only a part of it. Okay? Those pre-computed comment, you have a comment and then in parentheses, you have some example. So you should find in those parentheses which one fit with your analysis. It's okay? And then you should also check in the rule books. You have only at the end of your rule book some pre-computed comment. You should go and see that to avoid those comments. Okay? The goal is not to give you, it's important. The goal is not to give you a bad mark. The goal is to really show you how to perform analysis in bioinformatics, how to write it scientifically, how to make a good report, and so on. And then we give you, through the annotation, all of the aspects as the pre-computed comment in the rule book, so that you will make the less mistake as possible. That is really the goal, that you make the less mistake as possible. So I will enjoy if everyone really successful of this, because you respect everything. This is most important. It's really important for us to turn you as a good scientist instead of having only good marks. It's okay? Any question? No? If not, so I see the. Thank you. It was what? An Nguyen Van? Or okay. So this end this small lecture. We are going. I will stop sharing my screen, and then we are going to come back on your annotation. And then if you have question on your analysis, and if you want to share your screen, we will be free to, we will be glad to answer everything. It's okay?
I have a question from her. Do you want to ask question to Emerald?
You have a question from?
Yeah, from one of student, and she asked about she find the reference tree from the line map. Is this fine? So, for a reference tree in the field analysis, so we have two options. One option that she can find a tree from the paper, and
Yes.
we can find a tree from the line map website.
Yes.
So I think both options are fine, right?
Yes, both options are fine.
I have a question.
Yes.
Can I will share my screen. About the taxonomic origin of my ORF, because I see that it should be more specific until the species level. So in here, my ORF sequence is on the same branch with the with this with this one. So can I give a prediction that this my ORF is come from this bacterial porphyry? Like, can I give the conclusion that my hypothetical taxonomic origin is Porphyromonas? Because it's in the same node with the known bacteria.
In which level are you working now?
I'm working at the order level.
In the order level.
Yes.
So if you come back on your tree.
Yeah.
On the tree. So it's which one? Yes. That one.
Yes.
So it means that the order here, it's bacterial.
Just my input.
Okay. So from, if you are at the level of bacterial, it means that if you go down with your mouse, small, you go down, smaller, you go up a little bit, yes, down a little, no, with the mouse, don't move the screen, only the mouse. Okay, you go down, yes, that one. You see that branches? It's a bacterial tail. If you go down, it's also a bacterial tail. It means what you wrote C1 on the left, it's a monophyletic group. All of that are monophyletic group. So it means that your fragment belong to a bacterial tail. But you cannot say that your fragment belong to a porphyry something.
Okay.
Because to say that, you should make the same analysis but at the genus, it's a genus or a class. I don't. At the genus level, you see what I mean?
Okay, I understand.
Yes. But you can say that the closest member
Ah,
of your strain, okay, is the one, is if you go up a little bit, yes, that one is the closest member, but it's the closest strain.
okay.
So you can say that. But you cannot
Okay.
say that it belongs to a porphyry, something like that, because you are not sure. To say that, you need to make another tree, but at the level of genus.
Okay.
It was a genus or it was a family. I don't remember.
This was family.
It's a family, so
Yes.
you should build another tree at the level of family.
Okay.
Yeah.
Thank you.
You're welcome.
In the conclusion, so uh, when we write a conclusion, do we need to say like more specific, like according to this section or other section when we compare?
Yes, you can do that. Yes.
Yeah. Okay.
Yeah.
Thank you.